Hello, welcome to SMTech World. Today we are going to solve the day 8 of September LeetCode challenge. So today's problem name is sum of root 2 leap binary numbers. So let's try to understand the problem first, then we will try to design one solution for the same. Okay, so what they are saying, so suppose this is my binary tree, right? And they are saying, so since it's a binary tree, its nodes will only contain either 0 or 1 value. Okay, so you can see that the whole tree is contains either 0 or 1 value. So what they are saying that, so suppose this is my root, right? I need to traverse all the possible path to leap node. So what is leap node? Where the both childs are null, right? So if you check for 0, there is no more child, there are no more childs, right? So 0 is a leap node, 1 is a leap node, here again 0 is a leap node, 1 is a leap node, right? So I need to find all the possible path, and I need to keep tracking the numbers also, keep adding the numbers also, right? So suppose I start from here and I found my first leap node at 0, so my number is 100, and we need to convert that into a decimal number since it's a binary, right? So similarly we need to find out all the other possible paths. So here you can see this is my another path, right? 101. So again for 101, again we can, if I convert it to decimal, it is nothing but 5. Okay, similarly we can find two more paths. Here it is another path, right? 110. Again we are going to convert it to decimal, that is 6. Similarly, we have another path, that is 1111, right? So that is 7, and we need to add those all the results, and we need to return the decimal value, right? So this is the problem statement. So let's try to solve it using Java. So what is the algorithm we can follow here? So it's pretty simple. What we will do, we will use depth first search. Depth first means we will go till depth, we will traverse till depth. So I will start traversing from my root. At first I will go to extreme left. So from here I using depth first search, I will come here, again I will come here, and whenever I found a leap node, means both childs are null, we are going to consider this value and we are going to convert it in decimal. Okay, and once we are done, we will backtrack. So suppose I will backtrack to here 0, again I will traverse the other possible path, right? So this path. Again once we are done with this path, then again we will backtrack, again then we will traverse the right side. Okay, so this is the way the DFS works, right? So it's a basic DFS problem, and whenever we will going to traverse, we are going to keep adding the values, right? So let's try to implement the same using Java, and after that we will try to analyze the code. That will probably give you much better understanding. Okay, so what I need to do, we are not going to use any extra variable for this, so we can call our DFS function. So we are going to create one or define one DFS function, and we need to pass two things, the root and the initial value, right? So initial value will obviously 0, and from the DFS function we are going to calculate the whole value, all the values, and we are going to return the final value. Okay, so and we are going to call the DFS recursively. Okay, so for the main function we need to write this one single line of code only. Now quickly implement the DFS function. Again it should be a private, and we are going to return the integer value or some value. So return type will be integer obviously, and we are taking two parameters. One is the tree node, let us name it as node only. Another one is val. Okay, so value, that the value we are passing, initially it will be 0, right? So now what I will do, so I'm starting my DFS, right? So I am here right now. So whenever I am in, at first I need to check, is that node null? If it is null, then we can return 0. Okay, so at first we are going to check if root equals to null. Okay, so if root equals to null, then we can return 0, right? Let's do that. And else what I will do, I am going to declare another variable, probably let's name it as number only, and we are going to so suppose I am here, right? So now I am going to call this function, right? So I will convert this current value to a decimal value, and I will pass that, so that we can calculate the subsequent value. Okay, so we can do that simply using this. So whatever my value, I am going to multiply it with 2, and I am going to add the current node value, right? So it should be node dot val. Okay, and once we are done, then again we can return the function, and we need to check two conditions. So if it is my leap node, so we need to check the leap condition also, right? So whenever I will find my leap node, I am going to return my value. So let's check the logic for the same. So if my node dot left equals to node dot right is equal, means if the both value are null, then it will be equals, right? So in that case I am going to return my number value, right, num. Else if it is not null, non-null, then we need to traverse, right? So we need to call our DFS function twice, one for left side traversal, one for right side traversal. Okay, so it should be node dot left, and we are going to pass our number value, whatever we calculated, and we need to traverse the right side also, right? So DFS, again it should be node dot right. Okay, and we are going to pass our number, I think that's enough. I think we are enough. Let's compile our code and check whether it's compiling or not. Okay, I think it's throwing some compilation error. Let's quickly fix that. So it should be node, right, instead of root. Okay, our solution is compiling and it's giving me the expected answer. Let's quickly submit it and check whether it's accepted or not. Okay, our solution is accepted also. Let's try to analyze the code and analyze the time and space complexity here. Okay, so you can see it's beating the 100% of Java submission, and it's beating the 81.26 in case of memory uses. Okay, so let's quickly try to analyze the code quickly. So what we are doing here, so initially we are passing the root node and we are passing the 0 value. Okay, so now I am here, right? I will convert this particular 1 value to a decimal number, right, using this. So initially it will be 0 into 2 plus 1, so my value will be 1 only, right? Now again, so this check will fail, right? So since we have left node and right node, so it will call this portion of code, right? So it will not satisfy this first if condition, so it will not return num. Instead of, it will call the DFS function for left subtree and for the right subtree. Okay, so again we are going to pass this 0 node, and our value is initially we calculated it as 1, right? So we are going to pass it 1. So I know up to this point my sum is 1. Again, for the right side also, we are going to pass this node 1, reference of this node, and we are going to pass the value 1. After that, again, we are now here, right? So at first we will traverse the left side. So it's a recursive call, right? This portion is recursive call. So again, I will come here, again I will see that I will recalculate my value, right? So now my value will be 2 into 1. So here, right, it will come here and it will be calculated 2 into 1 plus my current value is 0, right? So it will be 2 only. And again, it's this particular node also have left node and right node, right? So again we are going to call this DFS function twice. Again here again we are going to call this 0 node, and we are going to, my current value is 2, right? Similarly here again we are going to call the 1 node, and my current value is 2, right? So again it will now come here 0 2. Here you can see that this condition will not satisfy. Again we will calculate our number. So this time it will be 2 into 2 plus 0, so it will be 4, right? Now in this case you can see that it has left node is also null, right node is also null, right? So in this case this condition will satisfy, and we are going to return 4. So that means I traverse one path and I discover one path, and that path value is 4, right? Now it will go backtrack, right? It will go back and it will check for this section also, right? This section. So similarly it will check for this section, then again it will go back and it will check the other portion. So this is how our code works. Okay, so if you look at the code, you can understand that the time complexity is order of n, right? Since we are traversing or we are visiting all the nodes, so time complexity is order of n. But in case of space complexity, we are not using any extra spaces, right? So space complexity is constant, you can say. I think that's pretty much for this video. If you like this video, please subscribe to our channel, and if you have still some doubt, you can ask me in the comment section. Thanks for watching. Bye bye.